All right, let's look how we test some equations for symmetry. So for each one, there is a specific way that we test for the symmetry. If you're testing for the x-axis symmetry, we're going to replace y with negative y. So negative y goes in for y. And then we see if we get back to the original. For the y-axis, we're going to replace negative x in for x. And for the origin, we're going to plug in negative x for x and negative y for y. Now, when we do this, we're looking to see if we get back to the original equation, whatever we start with. If we get back to the original, that means that it is symmetric to whatever we're testing. So that's really the key to this. So if I look at the first one are x to the fourth plus 2y to the fourth equals 78. So I'm going to test for the x-axis, and then the y-axis, and then the origin. And we'll see if any of these or multiple of these work. So for the x-axis, in this equation, in my given equation, I'm going to replace the y with negative y. So that's going to make this x to the fourth plus 2 times negative y to the fourth equals 78. Now, the only thing that's really different is the negative y to the fourth, so we have to think to ourselves, if I take negative y to the fourth power, if I multiply 4 of them, it will become positive, because negative y times negative y is a positive y squared, times another negative y is negative y cubed, times another one is positive y to the fourth. The even number of negative signs make it positive, the odd number keep it negative. And so you'll look at this. This is exactly what I started with up here. So that is the same. So it is symmetric to the x-axis. So that is a good one. It is symmetric to that. But we have to check all of these. So the second one I'll check, I'll go ahead and check the y-axis. Now y-axis, I'm going to put negative x in for x. Very similar. We get negative x to the fourth plus 2y to the fourth equals 78. Same concept, even number of negative signs, so that's going to become x to the fourth plus 2y to the fourth equals 78. That's the same as well. So it's also symmetric to the y-axis. You can probably see that this is going to be similar for the origin when I plug in both negative x and negative y. Because if I get negative x to the fourth plus 2 times negative y to the fourth equals 78. Same idea. Negative x to the fourth will become positive, so x to the fourth plus 2y to the fourth equals 78. And so that's true as well. So this one, all three worked out. Quite honestly, that doesn't happen all the time. Most of the time it's only one, but it certainly could be all three. All right, so let's look at our second example. Our second example is y equals x squared minus 1. So I'll go ahead and start with the x-axis. So if I replace y with negative y, I get negative y equal x squared minus 1. Well, this is not the original. I can try to get it to be the original, like I can divide everything by negative 1. If I do that, I get positive y, but then I get negative x squared plus 1. That's not the same as this up here. So this is not symmetric to the x-axis. So definitely doesn't work for x, and so we'd have to try the other two as well. Obviously, you have to try all three. And so the y-axis, we're going to replace the x with negative x. So that's going to give me y equal negative x squared minus 1. Now this is a good one because negative x squared, again, same concept, even number of negative signs is going to become positive. So that gives me x squared minus 1. That's the exact same as what I started with, so it is symmetric to the y-axis. Now we could check the origin. It's not going to work because it's never going to be for just 2, so it's going to either be for 1 or all of them. So if we look for origin, it's going to be negative y equals negative x squared minus 1. Now the x will become positive, but the y is going to stay negative, so we're going to be kind of stuck in that same thing. So we only have, in this case, the y-axis for the symmetry. So the big thing is just to look at these as our things that we will test.